What do I have to do first? Is this root isolated? Oh, it's not? What do I need to do? Subtract 9 from both sides. So I have to subtract 9 before I even mess with the root?
Yes.
Okay. Equals what? 5. Okay. Now is the root isolated?
No. There's still a little baby 3.
So what is the little baby 3 telling me? What kind of root it is, right? So is the root isolated?
Oh.
It is, right? The cube root is isolated. Up here, isn't there a little baby 2?
Yeah.
Yes, we just don't have to write it because it's the most common. So is this root isolated?
Yes.
Yes, so what do I do? How do I undo a cube root? Cube it. What is the cube root of 2x minus 3 cubed? Just 2x minus 3, exactly. And what's 5 to the third? 5 times 5 times 5? Close.
Oh.
What's 5 times 5? 25. What's 25 times 5? So how much money is 5 quarters?
125.
125. Does that make sense? Okay. Now solve this. Plus 3?
Divide by 2.
2x equals 128. And you said divide by 2 now? Okay. 64. Is it right? Are you positive? Oh, we should check. Oh, check. Okay. So 64 times 2. 128 minus 3. 125. Cube root of 125? 5, right? 5 plus 9? Does 14 equal 14?
Yes.
So is this the right answer? Yeah. Okay so far?
Good.
First step. Isolate which root? Is that always going to be possible? No. So choose one to isolate.
The
First one. Okay. Is it isolated? So this is the root I'm concentrating on then if you're saying we're choosing the first root. This one's isolated. How do I get rid of the root? Square it. I square both sides. Look what happens to happen on this side too. The left-hand side is 9 minus b. What's the right-hand side? 1 minus 9b. Do you notice that both roots went away? Isn't that nice? Will that always happen? No. But it sure is nice when it does. Because how hard is this problem to solve? If I add 9b to both sides and subtract 9 from both sides, what do I get? This is 0. This is,
10.
try one more time, 8b.
All right.
This is
Negative 8.
-8. This is 0. So to solve for b,
B is -1.
is it right?
You check.
Okay. 9 minus -1.
10.
10. So on the left-hand side, I have the square root of 10. I have a 9 times a -1, which is -9. So I have 1 minus a -9. 10. Do I care what the square root of 10 is? Or is it good enough to know that the square root of 10 equals the square root of 10?
That's good enough.
It's good enough, right? So is this the right answer? Mm-hmm. Okay so far? Okay. First step, isolate the root. Okay, done. Now what? How do I undo a square root? Square it. What do I square on this side? All of it. That's exactly right. I have to square all of it. So on the left-hand side, what do I end up with? 2x minus 7. What do I end up on the right-hand side, though? Oh my gosh, you guys are making me cry inside of my head right now. What does it mean to square something? Multiply it by itself. X minus 3 times x minus 3. What do I have to do here? Distribute. What's x times x? What is x times negative 3? And then negative 3 times x? And then negative 3 times negative 3. 9. So 2x minus 7 equals x squared minus 6x plus 9. What type of problem has this just become? I'll give you a hint. Start to the Q. Quadratic, right? If it's a quadratic, what do I need it equal to? 0. Yeah, 0. So let's subtract 2x from both sides, and let's add 7 to both sides. 0 equals x squared minus 8x plus 16. If it's a quadratic, how many answers should I get? 2, because the fundamental theorem of algebra says your highest exponent is how many answers? Yeah. So how should I try to solve this? Yeah, factor. I should always try factoring first, right? It's usually the easiest. What two numbers multiply to be 16 and add to be negative 8? Negative 4 and negative 4, right? Zero product property says what? What do I do with each one of these factors? Since when I multiply them it equals 0, I set each one of these equal to 0. X minus 4 equals 0, x minus 4 equals 0. So what does x equal? 4 and 4. So did I get two answers? Yes, they are the same. Is that allowed? Yes. Could they be different sometimes? Yeah. So what do I need to do next? Check, right? So 2 times 4, 8 minus 7. 1, what's the square root of 1? 1. So the left-hand side is 1. 4 minus 3. Does 1 equal 1? Yes. So I know that this is the correct answer. Do I need to check this one? Because if this one works, right? If they're the same. If they were different, would I need to check both? Is it possible to get two different answers and they both work? Yes. Is it possible to get two different answers and only one works? Yes. So just be careful about that. Okay? You ready for the next example? Two times the square root of x plus 5 plus 14 equals 12. Because what am I trying to do first? Isolate it. So if I subtract 14 first, I get 2 times the square root of x plus 5 equals negative 2. Is my root isolated? Well, why not? There's still the multiplier, right? We haven't had one with the multiplier so far, so I have to divide both sides by that multiplier first. So the square root of x plus 5 equals negative 1. Now what? Okay, God bless you. What do I get on the left-hand side? X plus 5. What do I get on the right-hand side? 1, because negative 1 times negative 1 is 1. Subtract 5 from both sides. X equals negative 4. Like, guys, do I really need to check?
If you're
Okay, fine. Negative 4 plus 5. 1. Square root of 1? 1. 1 times 2? 2 plus 14. Does 16 equal 12? Did I do something wrong?
No.
You're sure? Like you followed all my steps and you know I didn't do anything wrong. But something's wrong, isn't it? Because 16 doesn't equal 12. So the first thing we need to do is write our answer. What's our answer?
No solution.
And the next thing we need to do is understand why there's no solution. Okay? And I want you to come back up to this step right here. Right here. Ignore the baby 2's because that was us squaring both sides, right? Guys, when are we going to take the square root of a number and get an answer? That's negative. You won't, right? We didn't put that root sign in the problem, so when we take the root, I get always the positive, right? When will I take the square root of a number and get a negative? Never. So when I got to this step, I could have realized that's no solution. Okay? Now, part of the problem is that people think, oh, I got a negative answer. That's no solution. Didn't we get a negative answer on this problem right here, and then I plug it in and it worked? So is it the answer that's negative that's the problem? No, it's this step right here. When I have a square root sign on one side and a negative on the other side, the square root's all the way completely isolated, but it equals a negative number. Do you understand? Do you understand why it's no solution? Could you get here and go straight to no solution? Yes, hopefully. Okay? Now, part of the problem, though, is what if this was a cube root? Instead of a square root, what if it's a cube root? Can I take the cube root of number and get a negative number? Yeah. What's the cube root of 8? What times itself equals negative 8? Negative 2, right? Negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is what? Negative 8. So something, we have to think of a way to figure out when this is allowed and when it's not, right? Could I take a fourth root of something and get a negative? No. Could I take a fifth root of something and get a negative? Yes. Could I take a sixth root of something? No. Could I take a seventh root of something and get a negative? Yes. So just the ones that we've talked about so far, 2, 4, and 6, you can't get that root having a negative answer. 3, 5, and 7, you can have that kind of root and get a negative answer. So what is true about those numbers? Evens and odds, right? So if it's an even root, can you get a negative number? No. If it's an odd root, can you take it and get a negative number? Yes. Okay? So I need you to be really careful about that. Okay? I have one more example for you. Nine minus x to the 1/4 power plus 12 equals 15. 9 minus x raised to the 1/4 power plus 12 equals 15. I need to remind you of something we talked about on the commercial break just a second ago. What does it mean for something to be raised to the 1/2 power? Square root. So what does it mean for something to be raised to the 1/4 power? A 4th root, right? What if this, actually, can I change this real fast? Are you okay with that? It's going to mess up the answer. The answer is going to be ugly, but I need to do the example this way. I need to change this 1 to a 3. We're not going to do this problem all the way. You need to see what to do at the beginning. Okay? So what do I do first? First we have to isolate the root, right? So you guys are telling me subtract 12 from both sides. And in this case, is there a root? Well, there's a parenthesis with a power, so isn't that what I need to isolate? Isn't it really a root, though? Isn't it a 4th root? Since it's a fractional exponent, isn't it a root? So when I subtract 12 from both sides, what I get is 9 minus x to the 3/4 power equals 3. How do I get rid of this exponent? Raise it to the what? 4/3? How is 4/3 related to the power that's here? How is 4/3 related to 3/4? Do you remember what the word is called? Starts with an R. Reciprocal, exactly. Whatever this exponent is, take the reciprocal. 4/3. Now we're not multiplying 3 by 4/3. We're raising 3 to the 4/3 power. Does that make sense? So what happens on the left-hand side? What do I end up with? 9 minus x. Now on the right-hand side, if this was a nice pretty number like 8, right? If I would have thought ahead, if I would have made this a 7 instead and this was an 8, I could keep going on this problem. Do you mind if you would do that real quick, or do you want me to make up a whole nother problem? We can do this one? Okay, so then let's change this to, what did I say, a 7? If this is a 7 from the very beginning, I subtract 7 from both sides right here, which makes this an 8. Why does making that an 8 matter? Do you know the cube root of 8? Yes, you do, don't you? Do you remember on your exponential or exponent foldable that we made? On the back, we said something like a to the n over m power, and the numerator was the power, and the denominator was the root. And we talked at the time that it doesn't matter which one of these you take first, but usually taking the root first will make it easier. So what is the cube root of 8? 2. And what's 2 to the 4th power? 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Okay? So the numerator is the power. Denominator is the root. So we took the cube root first to make this a smaller number of 2. And then we said 2 to the 4th power was 16. Does that make sense? What do I have left to do to solve this? Yeah, if I subtract 9 from both sides, I get negative x equals 7. X equals negative 7. Do we panic right here and write no solution because I got an answer that was negative? No, right? Negative answers are fine. Go back up to the top up here. 9 minus a negative 7. 16, right? 9 minus a negative 7. 16. What's the 4th root of 16? What times itself times itself times itself is 16? 2. What's 2 to the 3rd power? What's 8 plus 7? 15. Does 15 equal 15? So is this the right answer right here? Yes? Good. Any questions? What do you do if you have questions during the lesson? Ask.